This is our first lesson in the radicals and function unit. This unit is going to combine those two different concepts together. Functions, which we did at the beginning of the year, but we're going to learn some more about functions and kind of put some things together. And then also radicals, which are a type of function as well. This lesson is going to specifically focus on just simplifying radicals and also what we call rational exponents. Remember that word rational? It really means fractions. And so today's lesson is going to basically just be really basic. Hopefully a lot of it will be a review on simplifying radicals and also fractional exponents. Okay, the first section over here says prior knowledge, and it's a question. How many of these do you already know? Take a minute right now, pause the video, and see out of these 9, let's see how many you already know how to do. So take a look at those, see what you can do. Okay, so let's take a look. And I'm going to go over these pretty briefly, but I do want to touch on some of the basic concepts. So check your answers on A, B, and C, x to the third, x to the fourth, and x to the fifth. How do you do that? Well, remember x to the sixth is like you have 6 x's all being multiplied together. And the square root means you want to group them in groups of 2. And so I've circled groups of 2, and I have 3 groups of 2, so that is x to the third. Example B, similar deal. We have x to the 12th. That means we have 12 x's. But this little 3 in the corner means that it's not the square root, it is the third root, or also called the cube root. So this time I want to group them in groups of 3. So I have 12 of them, I circle my groups of 3, and I have 4 groups. And so x to the fourth is my answer. Same thing on example C. I just didn't want to write out all of those 20 x's, but you can imagine if you had 20 of them, you group them in groups of 4, there would be 5 groups, and so that is x to the fifth. That is the basics of how to do radicals and roots. Now we're starting to mix in some numbers with our x's, and so the numbers you should already know how to do, but I'm going to just quickly go through that. 32 is the product of a perfect square of 16 and 2. Now we're taking the square root of these, so the square root of 16 is 4, and the square root of 2 is just square root of 2. We leave it inside. X to the third, we're going to do what we did a minute ago. We're going to go through and we're going to group those together in groups of 2. Well, we have one group here, and so that comes outside and becomes an x because it's one group. And then we have one that's left over and it has to stay inside. Next example, 80, once again, is 16 times 5. 16 square root of that is 4. 5 stays inside. X to the fourth, because it's a square root, we would have 2 groups, so that's x squared. Example F starts getting into cube roots, and so we have to remember our cube roots. So 2 times 2 times 2 is 8, and so that is the cube root of 8. And then the x's, once again, 2 groups of 3, because it's the cube root, we want to group in groups of 3, and so that is 2x squared. Last set here, again, 625. If you didn't have a calculator, you might not know that, but 5 times 5 times 5 times 5 is 625. So the fourth root of 625 is 5, and the fourth root of 12 is 3, because 12 divided by 4 is 3. 50 is 25 times 2, so we get that. The x squared is the perfect square, so it comes out. And when you have a fraction, you just take the square root of the numerator over the square root of the denominator. Okay, those are some basics. Again, I'm curious as to how many of those you got right without my help. I'm not sure how much of the prior knowledge you have or remember, because it's been a while. So let's go ahead now and start talking about different operations. I'm starting with operation of exponents, which is a concept that we learned in our last unit. Like, we've done exponents before, but the thing is I'm bringing those in because we're going to look at how about rational exponents. That is, how about fractional exponents? Remember when you have x squared times x to the third, that is x to the fifth, right? We add those together to get x to the fifth. because once again, you would have 2x's here and then 3x's here. That's a total of 5x's. So in other words, we are adding. So on 1b, that's what we need to do. We need to add 1/2 plus 2/3. And hopefully we know how to add fractions. For fractions, we have to have a common denominator. Common denominator here would be 6. So that is 3/6 plus 4/6, which is 7/6. So this simplifies to x to the 7/6 power. Let's look at the next one. When you have a power of a power, you multiply those. That's going to be x to the 8th. Okay, same thing here. We're going to take a power of a power, we multiply those, and 6 times 1/2 is 3. Lastly, when we had things like this, where we have a power outside and we've got more going on inside than just one item, we basically distribute that, and so that gives us x to the 5th times y to the negative 20th. But remember, negative means it goes in the denominator. So it's x to the 5th over y to the 20th. And so same thing here. We're going to multiply this. So we get x to the negative 3rd and y to the 1/2. Negative 3rd means it has to go to the denominator. Y to the 1/2 is going to stay in the numerator. And this is one that's this is a little bit new to us. You might not remember this, maybe you do. 1/2 power means square root. And that's something we're going to focus on today. So if you didn't remember that, that's okay. We're going to talk about that today. So when you have a number, this number is called the base. This top number is going to be your exponent. The bottom number is going to be your root. Let's look at some examples with 9. We know that 9 to the 3rd means 9 times 9 times 9, and that is 729. That might not have been something you knew in your head, but it's something you could find on your calculator or other means. 9 squared is 9 times 9, which is 81. 9 to the 1st is 9. 9 to the 1/2, and I mentioned this just a second ago, is the square root of 9, and so that's 3. 9 to the 1/3, well, 9 to the 1/3 is the cube root of 9. And the cube root of 9 actually does not simplify. It's not 3, because 3 times 3 times 3 is not 9. It doesn't simplify. That's as far as it can go. So a 1/3 power means a cube root. A 2/3 power means the cube root of 9 squared. It means the cube root of 81. And that actually does simplify. We're not going to get into that right this moment. We're going to get into it in a minute. But that will simplify. But for now, I'm just going to leave it like this so you know what we're talking about. Anything to the 0 power, do you remember? Anything to the 0 power is 1. Okay, negative exponent. What's a negative exponent mean? It means 1 over. So this is 1 over 81. All right, again, I'm focusing in this video on basics. So I'm going to go through the basics of what does this all mean? So a 1/2 power does mean the square root. So this is the square root of 9. And the square root of 9, hopefully everyone knows that one, it is 3. Okay, in this case, I'm going to kind of go backwards and I'm going to say, well, the base is 9 because that's the big number. The big number is the base. And that the factorization of that, well, 3 times 3 is 9. That's how I knew that the square root of 9 was 3. Again, hopefully obvious. Okay, 1/3 power is the cube root. Now, I should say on the square root, we don't usually write a little 2 in that corner, but if you want to remind yourself, you can. It's kind of a good idea to do that. I don't usually do that because I just understand it, but if that helps remind you, put that 2 in the corner. Okay, so this is a 3rd root, a cube root. And again, it goes in that little corner. You have to kind of stick it in there. And it is negative 8. When we did square roots, square root of a negative was an imaginary. And typically we say we just can't do it. What about cube roots? Well, let's think about it. I'm going to say the answer is negative 2. And how did I get that? Because negative 2 times negative 2 times negative 2, That's a negative, times that is a positive, back at the negative. So you can take the cube root of a negative number. Cube root of a negative number is going to be a negative. All right, 81 to the fourth. That is the fourth root of 81. And once again, I'm going to say that answer is 3. How do I know that? Well, I'm dealing with 81, and 3 times 3 times 3 times 3, well, that's 9 times 9, which is 81. So the fourth root of 81 is 3. In class, I'm going to give you a handout that has some of the common roots on it, and this would be one of them. Last one, cube root of 1,000. Well, you're basically asking yourself what times what times what 3 times is equal to 1,000. So our base is 1,000, and we're deciding what times what times what would give me 1,000. Well, it's 10. 10 to the third is 1,000. Okay, again, basics. Let's turn the page. Okay, can we do this with fractional exponents? Okay, that's what we're kind of learning in this section, is dealing with fractional exponents. Remember, the top number is your power, the bottom number is your root, and we wrote that on the last page at the bottom. Top number is the power, bottom number is the root. So first step I'm going to do here is I'm going to rewrite this, and I'm going to say I'm looking for the square root of 25 to the third. Now, I know a second ago I said I don't usually do that. I'm doing it because we're learning this, and this is going to help us out. Over in the margin, I wrote down that you can do the exponent first or the root first. It does not matter. It can work either way. I personally, off the top of my head, I don't know what 25 to the third power is. But I do know what the square root of 25 is. Square root of 25 is 5. So this is 5 to the third. And now, actually, that number is low enough that now I do know this number in my head. It is 125. So when you have these problems, you can either do this exponent first or the root first. I just do whatever I know in my head. Okay? Now, can you use your calculator? Well, sure, but we're going to start getting into some that have some variables in them, and your calculator is not going to help. Okay, next problem. Once again, this is which one is the root, which one is the power? So it's going to be 8 to the second with a third power in the corner, the cubic in the power, cube root in the power. And again, you can do either one first. So if you know what the third root of 8 is, you could do that first. That's 2. Or, if you don't really know that, but you know 8 squared is 64, you could take the third root of 64, and maybe in your head you know that 4 times 4 times 4 is 64. So that works out that way. You can do either one first. Okay, a minute ago I referred to that we're starting to get into some variables, that you can't always use your calculator because we're going to have some variables. In this section, what I want you to do is I either want you to simplify it or rewrite it as a fractional exponent. And so this first one, there's not really a way to simplify that, so I'm just going to write this as a fraction. Okay, number 2. Maybe let's start off by writing it as a fraction. Remember, the power goes on the top, the root goes on the bottom. And now that fraction, that can be simplified, so it's just x squared. And maybe some of you know the rule there is you take that and you divide it by whatever's out here. So 6 divided by 3, that's what we wrote down, is x squared. Okay, so these are both fifth roots. If they have the same root, you can put them together. In other words, I can rewrite this as the fifth root of x to the 20th. And I'm getting that 20th because 2 plus 8 is 20. When we multiply these, we're supposed to add the exponents. All right, now I have x to the 20th to the fifth power. That does reduce down to x to the fourth because 20 divided by 5 is 4. Or I have 20 x's lined up. I circle how many groups of 5? 4 groups of 5. Number 4, once again, since they are both under the same root, I can just consolidate them under the same root. They're both cube roots, so I can put them together like this. So I have x to the fourth over x. Well, I know that x to the fourth over x reduces down to x to the third, because I just subtract those, we know that. And then the cube root of x to the third is x. If you wanted to think of it as a fraction, you could say 3 over 3, because 3 on the numerator, 3 on the denominator, that's x to the first. Now, we could do that with number 4 because they were the same root. And we could do that with number 3 because they were the same root, so we could consolidate them. Number 5 does not have the same root. So what do I have going on here? Well, I have x to the 2/3 power over x to the 1/2 power. And what are you supposed to do when you have powers on top of each other like this? You're supposed to subtract. So I need to subtract 2/3 minus 1/2. Once again, I need common denominator. So really what I have is 4/6 minus 3/6. So that is x to the 1/6 power. Pay attention to instructions on a test or an assignment or something on whether you should leave it as 1/6 or whether you should leave it as the 6th root of x. The instructions will tell you which way to go on that. The main thing is you understand how to subtract, and there you get that from subtraction. Last section, simplifying radical expressions. We kind of did this the very first section, but it was just that little quiz part, so I didn't really go in depth. What we need to do is we need to simplify that 8, and 8 simplifies down to 4 times 2. I chose 4 because it's a perfect square, and x squared, I need to take the square root of each of those different pieces. So this first one is going to be 2 on the outside and 2 on the inside. And this one, x squared, the square root of that simplifies down to x. So my answer here is 2x radical 2. 375. I said a minute ago that I'm going to give you this piece of paper in class that has some perfect cubes on it. But I will tell you right now, some of the perfect cubes, starting with 2, 2 to the third is 8, 3 to the third is 27, 4 to the third is 64, 5 to the third is 125. There are more, but what I'm looking for is, do any of those numbers go in to 375? Well, yes, 125 goes in evenly. So 125 goes in evenly, it goes in 3 times. And once again, my x to the fourth, I'm looking for groups of 3. So I'm going to write it like this and show you what I'm going to do with this. This is the cube root of all of this. So I could write the cube root of this and the cube root of this. So what that's going to be, the cube root of 125 is 5. And then my other 3 here, it is stuck inside the radical still. The cube root of x to the third is x, because 3 over 3 is 1. And then this x gets stuck inside. So my answer is 5x times the cube root of 3x. I keep talking about that little piece of paper. I have the powers of 2 on that paper. So 2 squared is 4, 2 to the third is 8, 2 to the fourth is 16, 2 to the fifth is 32. So 32 is actually 2 to the fifth power. And this x, I want to define it in terms of 5. So like x to the fifth, x to the fifth, x to the third. Or if it would be easier for you to think of that as x to the 10th times x to the third, you could think of it that way. But I'm finding the 5th roots of all of this. And so the 5th root of 2 to the 5th is 2. And these two x's are both going to come out. There were 2 of them, 2 groups of 5. And then I had left over x to the third, and that's inside the 5th root. That's kind of messy. I'm going to rewrite that. Okay, 2x to the second times the 5th root of x to the third. All right, now we have a third root. So again, I need to think about my cubes. I've got my cubes over here. 27 is a perfect cube. This is, and I could call it negative 27 because cubes can be negative. So I'm going to call this a negative 27 times 2. I have my third root. So I'm going to go with x to the 6th times x squared. And that one is just going to work out. So I'll just call that y to the 12th. And I'm taking the third root of all of this. The third root of negative 27 is negative 3. And I have 2 groups of 3 here. And I have 4 groups of 3 here. And I'm talking about the cube root. So my leftover things that didn't come out were this 2 and x squared. Okay, negative exponents. Remember we did this a while ago also. But remember that 9 to the 1/2 is the square root of 9, which is 3. Compare that to 9 to the negative 2 power. 9 to the negative 2 is 1 over 9 squared, or 1 over 81. Don't get those two confused, because I know those are confusing. Well, then what happens if we put them together? Of course I had to do that, right? So here we're going to put them together, and that means the negative means take what you are working with and turn it upside down. Now I have a positive, because all I had to do was flip it for the negative to go away. So in other words, what I have is I have 27 to the 2/3 over 8 to the 2/3. Remember, the bottom number is the root, the top number is the power. And again, you can do either the power first or the root first. I happen to know that 27, the third root, the cube root of 27 is 3. And so now I have to take 3 squared, and so my numerator is going to be 9. On the bottom, again, you can do it either way first. I might just, since I did that one that way, I'm going to go the other way on this one. So in other words, I have the cube root of 64, and what times what times what is 64? Well, 4 times 4 times 4 is 64. So this answer is 9/4. 9/4 is also one of those fractions that everyone says, can't you simplify that because you can take the square root? No, you can't. You could only do it if like 3 went into both of them or 2 went into both of them, but there are no common factors. You cannot just take the square root. It's not going to be the same thing. 3 over 2 does not equal 9 over 4. Okay, that is the end. Remember, in your notes, if you have questions, you write them down in the margins. So go through here, see if you have any questions that you need to write down in the margins. Tomorrow in class, we're just going to work more on some of these basics. This is a really basic lesson. We're going to ramp our way up.